Hello everybody. Okay, so I've been doing sliding window problems for some time now, and I think it's time that I start focusing on some other data structure. I've chosen heap. So this is the first video in the heap series. This is the problem: kth largest element in an array. Heap is essentially a priority queue, and even though this question is based on heap, as you can see, it's not really a heap question. For example, it's very easy, by the way, to solve this problem. Given we are given this array of integers, and we just have to return the kth largest in the array. So this array is not sorted. What we can do is we can sort the array and then return the kth. From note that it is kth largest element in the sorted manner, not kth distinct element. Yeah, so after sorting, we can get the kth element. That's easy. But here we can't sort, right? So what we can do is we can have a priority queue of type integer, and what I can do is I can iterate over my list for each num, and I can add this element into my priority queue. Then I can check the size of the queue. If my pq's size becomes greater than k, then I can just remove the first element in the queue, and then I can return peak. Expected vol pq priority queue of type int. What is Java? It's not a function, it's a property. Okay, and yeah, that's all. Yeah, that was easy using priority queue. There is another way to do this, and that involves making a sorting algorithm. Something like what's the name? I'm forgetting the name. QuickSelect sort or something like that. Let me check. Saw this somewhere here. Not this. This is the code. I want to look at the code. QuickSelect is quicksort sibling. So we partition around a pivot so that the pivot lands in its final sorted position. Then we recurse only into the side that can contain the element. With a random pivot, QuickSelect runs in expected linear time and constant memory, which is typically faster than common min heap when k isn't tiny. Yes, this program takes extra memory, using priority queue. We can do it in constant time. And yeah, let's try to like build this algorithm, QuickSelect. What are the steps? The kth largest equals n minus k in the sorted array. Pick a random index in the current right. Pick a random index in the left, right, swap to the end, and then so much partition, just a random. Move all elements. Move all element smaller than or equal to pivot to the left. Return the pivot's final index. Okay, let's try. Um, partition around a pivot, so the pivot lands in its final solid position. So we know we need a random pivot, right? A random number. So what are my left and right here? Left is 0 and right is last index, nums dot last index. And random pivot is equal to left and right random. Guess this is the method. Okay. We partition around a pivot so that the pivot lands in its final. We recurse only into the site that can contain the answer. With the random pivot, QuickSelect. Okay. Target index equals in a sorted ascending random pivot. Okay, so now I have a random pivot. I need to move all elements smaller than this pivot index to the left of the array, right? So that's like random pivots first index. How can I or current is nums dot random pivot. That's my current element. Now how do I check, how to find all the elements that are smaller than this number? Let me find some, I don't know, explanations on it. Go with the heap. Do a partition. Get the pivot. Pivot is less than target. Repeat on the left side. Oh, repeat on the left side. Otherwise repeat on the right side. Make a growing buffer on the left. Do a partition. Okay, we randomly chose a pivot, and then between left and right, and then based on that we partitioned our array into two parts. So yeah, so we have left and we have right. If pivot is less, make a growing buffer on the left. Choose the pivot value which to compare all the elements. Put the buffer size now is the pivot position in a sorted array. I don't understand how to like traverse the array. Should I like go from left to right, or choose a pivot value? So I can say while my left is smaller than right, what is the intuition behind QuickSelect? I will find key from QuickSort's partition idea, but instead of sorting everything, we only explore the part that contains the kth element. Core idea. When you partition an array around a pivot array, there is a pivot. All elements smaller than pivot go to the left. All the larger elements go to the right. Pivot ends up in its correct sorted position. So this is the array, and if we pivot around four, okay, now 4 is exactly where it would be in the sorted array. Choosing a random number and then pivot around it. If the pivot ends up at index p, then p is equal to k, we found. If p is greater than k, find third smallest. So k 0, 1, 2, third smallest. 1, 2, 3. Let's add 3. Choose a pivot. 4 at index 3, but we want index 2. So we go left. Alright. On the left, we have 3 elements. Choose pivot 3. Alright, we are choosing a different pivot every time we we partition the array. Okay, I got at least got some idea of it. Now the implementation step. How should I implement this? Well, in that example, it always considered the last element as the pivot element. So am I supposed to use that, or and this I also need to do this step where I put all the elements in the right order. 2, 1, 3, 4, 5, 6, 8, 5. They don't have to be sorted. Yeah, they don't have to be sorted. We only want elements that are less than this element on the left and greater than the rest of the element on the right. Okay. Let's see. Left and right, and a pivot. Okay, let's just swap this with the create a function for swapping. Private swap and use int array. I G nouns I J is temporary. Okay. let's see. I have this array. And let's say this is the random pivot. I'm swapping my pivot with the last element in the array. So 4 takes this, they like switch positions, and now my array is 3, 2, 1, 5, 4, 6. Does that help me in any way? I'm still confused about the swapping part. How do you like decide the position of the okay. How to choose a pivot? Random because random index between left and right because it avoids all of this. Okay. Many implementations simply use for sorted arrays. Okay, let's just choose randomly, and I think this is the right way. Next, random dot next index. What about swapping? Oh, just nums for each, print, not print a new line, just print the number. Exactly, it chose the last element as my random and just swapped it with 2 at first index. So 3, 4, 1. Now, like, what to do now? Okay, choose 4, index 3, pivot index is 3, but we want index 2. But we have to look. We have to check index at the end after we have. So after choosing a pivot, how can I find? I want to find the elements. How can I find the elements which are smaller than the pivot and swap them? Choose a pivot. Scan the array from left to right. Every time you see a value smaller than, move it to the left side. If 5 was my random 0, 1, 2, 3, if 5 was my random pivot, then I would 5 is at index 0, 1, 2, 3. It's at index 3. Alright, so I will check from left to right. Is 3 smaller than 5? Yes. Is 2 smaller than 5? Yes. Is 1 smaller than 5? Yes. And 0 is 5. Is 4 is 6? Is 4 smaller than 5? Yes. Now here we do the swap, right? So let's see. So number 5 is at last index, and my pivot index doesn't change. So now 4 has taken the place of 5. Let's start 0. I is smaller than nums at pivot index. If that's the case, no. If it's smaller than, if it's greater, I don't know. I don't know. This is not right. This is not right. I want to cancel. Can I like use the middle index? This is the target we are looking for. Target. Pick a random index and swap it to the end. Yep, this is what we're doing here, swapping it to the end, and then just with the random pivot. We want smaller than or equal to this pivot to index. If 4 was my pivot, then this is wrong. What is my pivot? Oh, okay. Start, end, and pivot index. Find pivot, random pivot, swap it with, okay, pivot index, pivot. All right. Because we swapped it with the last one. Wait, okay. Pivot is right. Okay, and I have to check pivot here. Pivot. Okay, start and end are actually are being passed in to this function. So find pivot. We start from 0. So we start with the entire array. Num, yes, initially the entire array. Okay. Okay. So let's try to visualize. This is my start. This is my 0, 1, 2, 3, 4, 5. This is my end. And we have some random pivot between this. Pivot index. Pivot index. Let's call it pivot index. Start. Pivot index. Pivot index. Pivot index plus plus. at the end before returning. We're swapping the pivot index with the I wonder why we are doing this. Okay, so let's not do that and simply return pivot index. Pivot index and find pivot given nums array and a left starting from 0 and is at nums dot last index while my start is smaller than and find me a pivot. Find pivot nums start and end. Return 0 for now. Let's do this and this. If pivot index is num well, I need last index minus k, right? K minus 1, k minus 1. Okay, but we are actually using last index not the size of the num. So I think it's k is fine. If that's the case, we can simply return pivot index or the element at this index. Break. If the pivot index is smaller than k, what does that mean? Okay, I went out to get some fresh air. When my pivot index is less than k, that means I need to start looking on the right side. So I update my start. Else, I need to start looking on my left side. So pivot index. Okay. We haven't sorted our array in any way. Cannot be applied to unit. Oh, let me make it return int 7 line 36. Okay, what am I trying to reassign here? All cannot be reassigned. Number 36. War. K minus 1. K minus 1. Mhm. I was not recording. The mic was off. Okay, so I was saying that, okay, I am convinced this works, of course, but I don't see it yet. Like, I have, I've got the pieces, but it's not still like the whole algorithm as a concept is not in my head. And yeah, I need to try run this on probably write down using pen and paper. Yeah, maybe yeah, and of course I'll come back to this problem in a couple of weeks when I have sufficiently forgotten this and probably go through the entire process over again. Okay, yeah, then there was a video for today. Thanks for watching.